Next, we're going to be talking about parametric equations. And what a parametric equations are is taking the vector equation and breaking it in half. Part for x by itself and part for y by itself. For example, the equation that we just did, xy equals 5, 3 plus t times negative 3, 4. I can write this as two equations, one for x and one for y. I could say that x equals, just looking at the x components, 5 minus 3t. And I got that by just taking the x value and then taking negative 3 and multiplying to t here, because negative 3 is the x value. So x equals 5 plus t times negative 3, which is negative 3t. Similarly, the y values, y equals 3 plus t times 4, or 4t. And those two equations are called parametric equations, where t is the parameter. And what a parameter is that, we just choose a value to calculate a specific thing. Like in the previous problem, we, said to calculate where the object reached. We can plug in like the amount of time it has been traveling, like a 3/4 of a second, second and a half, all of that. So t represents that parameter. An example is an object moves along a line where x equals 1 minus t and y equals 1 plus 2t. When and where does the vector cross the line with the circle, with the following equation? X squared plus y minus 1 all squared equals 25. So to figure out where two equations are equal, we gotta either set them equal or substitute one in the other, or solve by elimination, those algebra methods that we know. So I guess it would be an easier route if we can just substitute x and y in the circle equation with the x and y quantities in the parametric equations to figure out or solve for t, or the time. So let's do that. So instead of x, I can put 1 minus t, because that's what I have as an equation. Instead of y, I can put 1 plus 2t right here. And I can solve for t. By foiling this, first quantity I get 1 minus 2t plus t squared, because if you FOIL correctly, you'll have a trinomial. And for this one, as you can see, I have 1 and negative 1, so that goes away. So that's 2t squared, or 4t squared equals 25. And by combining like terms, I get this quadratic equation that I can factor or use the quadratic formula to solve. This is factorable. So after I factor, I get 5t minus 12 for the first factor, and the other one is t plus 2. If I set each one to 0, I get t equals 12 over 5, or t equals negative 2. So this is the first answer to when. When does it cross the circle? Well, 2 minutes or 2 units of time ago, and at that time 12 over 5. So how would I know where is the second part? Well, where is just the x and y coordinates. So if I take the t and plug it in x, and y, I get the first point, and then take the other t, plug it in x, and plug it in y, and I get the second point. So let's do that. So again, negative 2, plug it in here for the x, that becomes 1 minus negative 2, or 1 plus 2, so that's 3. Take the negative 2, plug it in for the y, so 1 plus 2 times negative 2, or 1 plus negative 4. 1 minus 4 is negative 3, so that's the x and the y. Same thing with this one, just you'll need to get a common denominator. 12 over 5, plug it in the x in the original equation. 1 minus 12 over 5, which is 5 over 5 minus 12 over 5, you get negative 7 over 5. And then plug the 12 over 5 again in the y equation. You'll get 29 over 5. So this answers the where. So when does it cross? Well, at this time, 12 over 5 and negative 2. Where does it cross? 3, negative 3, and negative 7, 5, 29, 5. Well, it doesn't stop there because sometimes they ask you to draw a picture representing that. So let's look at what we can do here. To draw a picture, I can draw a picture for that circle because I know that the equation for the circle is x minus h all squared plus y minus k all squared equals r squared. That means the center is h and k. In this case, the center is 0, 1, and the radius is 5. So that's the center at 0, 1 right here, and then we go up 5, so all the way to 6, because from 1 to 6 that's 5 units, and then down 5, so all the way to negative 4, right 5, left 5, and we draw our circle. I'm sorry, my circle is not that great, but yeah. Okay, so again, so drawing the circle isn't the issue. The issue is that situation over here. So that represents a line, or the two parametric equations represent a line. How do I draw that? Well, we gotta find a Cartesian equation, or an equation for the grid. So the Cartesian equation is in the form of y equals mx plus b, for example. It just gotta have x and y. So in that case, I gotta get rid of the t. So I'll take the equation x equals 1 minus t. I'll solve for t, then I'll plug in the rest of the equation here to get rid of, or substitute it for that t to get rid of it, and plug in x instead. So let's see how that works. So x equals 1 minus t. If I subtract the 1 and divide by negative 1, I'll get that t is equal to negative x plus 1. So I'll take negative x plus 1 and go back, plug it in, y equals 1 plus 2t. So if I plug it in negative x plus 1 instead of that t, I get y equals 1 plus 2 times negative x plus 1 instead of plus 2t. So I'll distribute the 2. I'll get negative 2x plus 2 plus 1 is a plus 3. So I distributed and combined like terms. And that's really the equation that I can graph. So let's graph that. So as you can see, the line crosses the circle at two distinct points. The point that, my graph isn't that great, but the point that we found is 3, negative 3 originally was one of the crossing points. Again, my graph could be a little better. And the other point right here is negative 7 over 5, 29 over 5, or like if I change it to decimal, I would see that it's like negative 1.4, 5.8. So we're close. Negative 1.4, like 1.5 almost, and 5.8, so close to 6. So if they ask us to graph it, that would be the graph, and just gotta find that linear equation. And that's it. Oh, well, last thing that the book mentions is talking about the direction of a vertical line and a horizontal line. So just so that I can clarify that, the vertical lines have a direction of any vertical line, really, like in this direction, or any vertical line on the grid hitting at any x point have the same direction. They all go vertical, and if we start from the x-axis, they're all going in the direction of 0, 1. So the direction of a vertical line is always the direction or the vector, like component form of the vector, direction vector, is 0, 1. And that's because just going up, if we start from the x-axis, it goes up to 0, 1 or towards that. Even if it's not exactly, on the y-axis or anything, that's just the same direction. They're all parallel in that direction. Same thing with a horizontal line. A horizontal line, again, could be anywhere, and they always say like from the y-axis is going towards 1, 0, whether it's on the x-axis or not. That's just the direction of where it's going, 1, 0. And that's the last thing that this section covers. Hope this helps. Thank you.